In this first problem, we already have a common denominator, so we can keep the x minus 2. And across the numerator, we can just add and have 8. Now, we cannot reduce the 2 and the 8 because 2 is not a factor of the denominator. It's in a subtraction problem. In this next problem, again, we have x plus 4 as a common denominator, so there really is no trick. So all we're going to do is add across the numerators. X plus x is 2x, and 3 plus negative 5 is negative 2. Now, we can leave our answer there if we realize that this will not reduce, or technically we should be factoring a 2 out of the numerator and verifying that indeed there will be no reduction possible afterwards. So in this case, either one of those is a correct way of writing the solution set. Now, problem number 3 is a subtraction problem, and the common denominator x minus 3 will remain. However, there's something you've got to be careful of with subtraction. We need to subtract both portions of the numerator. We need to distribute that negative. This numerator actually becomes x plus 7 minus x minus 5. So please be very careful here. The x's are going to cancel each other out when we subtract, and we're going to have 2 over x minus 3 as the simplification. Now we start into problems where we have unlike denominators. This first denominator will factor into 3 times x minus 5. Now, the second one, we'd really like to have an x minus 5 there, and we know from the -1 technique that 5 minus x and x minus 5 are opposite in sign. So what I can do is make that change if I go in here and change this minus sign into a plus sign. Now we've adjusted for the little switch that we've made. We can now state that the common denominator is going to be 3 times x minus 5 and begin the addition. This first fraction has no change down below, so the numerator will remain 4. And this second fraction has us multiplying by 3 in the denominator, so we'd need to multiply by 3 up in the numerator also, and that will give us plus 3x, and that is our simplified version. Now on number 10, let's find the least common multiple between these two denominators, and that will be 15xy to the third. And in order to do our addition, we need to see how our denominators have changed. To go from 5 to 15, we've multiplied by 3. We already had the x, we already had the y to the third. So our 4 up above is going to get multiplied by 3 also, and this will become 12. Our second expression, going from 15 to 15, no change in the coefficient. It looks like we've multiplied by an x and a y. So our 2 up above is going to get multiplied by an xy also, and that will become plus 2x squared y. Now, we would reduce this, or attempt to reduce this. I notice that I can factor a 2 out, and that's it, but a 2 will not cancel with that 15. So I'm going to just leave this as my simplified form right there without factoring out the 2. For this next problem, the least common denominator is going to be the product y times y minus 1. Now this first expression is getting a change down in the denominator by multiplying by y, so the 6 up above is going to get multiplied by y also, giving us 6y. I will put my plus sign down right now and see about converting the second fraction to an equivalent form. The y gets multiplied by y minus 1. So up above, the 9 gets multiplied by a y minus 1. And I can either write that as 9 times y minus 1 or 9y minus 9 if I want to do the distribution right off the bat. Now I can add like terms in the numerator. This gives me 15y minus 9 over the y times y minus 1, and that could be the form that we write our answer in if we're looking forward. Some of us might note that we can factor a 3 out of the numerator and write that numerator now as 3 times 5y minus 3 over y times y minus 1. But since this does not reduce, we're perfectly fine leaving it in the form that I've put a box around. Number 12 is another problem that makes use of the -1 technique. Notice the denominators are the same except they're switched around. If I change the 8 minus n in the denominator of the second fraction into an n minus 8, I've changed the sign of that second fraction. And I can counter that or undo that change by changing the minus sign into a plus sign. Now I can add across with a common denominator of n minus 8. And up in the numerator, I will have 4n plus 2n, which is 6n minus 1. And that will be my simplified form, and it does not factor and cancel. For this next problem, I need to factor my denominators into a plus b, a minus b, and a times a plus b in order to determine what the least common denominator is going to be. Now, my least common denominator is going to need to have an a out front because of the first fraction, and it will need these two parentheses because of the other fraction, a plus b times a minus b. Now I need to see how have I converted these fractions to these new denominators. This first denominator has changed by multiplying by a, so I need to multiply the 6a up above by an a also, and that will give me 6a squared. I then have plus 2a there already, and this second fraction is getting multiplied by a minus b down below, so we need to multiply by a minus b up above, and we now have a minus b. A very common mistake is to cancel these a minus b's. That a minus b is not a factor of the numerator. It's got that addition sign up in that numerator, so you cannot cancel those yet, even though you see the two parentheses and it seems very tempting.